Welcome to Algebra 2, section 3.4 today, quadratic formula. All right, for our introduction, we're going to kind of build off what we learned last section and complete the square to obtain the solutions for. And you can see here we've got just a general quadratic equation set equal to 0, a quadratic function set equal to 0. So we don't have numbers, we have variables. And so that's really going to help us maybe work through and find a pattern so we don't have to go through the steps of using the completing the square each time. So let's see what this gives us. If we're going to complete the square, what we want is ax squared plus bx, and then we'll complete the square there, and that's going to equal negative c, right? We want to subtract the constant over to the other side. Now, before we kept going with completing the square, we got rid of this a term. Right, so we need to divide both sides by a in order to get a 1x squared. So that gives me 1x squared plus b divided by ax, and then we'll be able to complete our square equaling negative c over a. All right, if we wanted to continue, we would take that b term, in this case it's b over a, and divide that by 2, so b over 2a. And we would square it to fill in the blank. So here, if we square that, we get b squared over 4a squared. Whatever I add to one side, I have to add to the other. Right? And now we have a perfect square trinomial, x plus b over 2a squared equals, and now if I wanted to combine these together, all I would need to do is get a common denominator. So this negative c over a, I need to multiply that by 4a over 4a. Then I get negative 4ac all over 4a squared plus b squared over 4a squared. It's a little bit trickier working with only variables, but we still have the same concepts to work with. All right, so we've got x plus b over 2a squared equaling, let's combine this together. I'm going to call this b squared minus 4ac all over 4a squared. And that's just to have the positive number first. That's all, just organization. And now we're ready to take the square root of both sides. Square root cancels out the square, so we've got x plus b over 2a equals plus or minus square root of b squared minus 4ac all over 4a squared. Now when we square root a fraction, it's the same as taking the square root of the top over the square root of the bottom. So I've really got plus or minus square root of b squared minus 4ac, and that's all over the square root of 4 times the square root of a squared all over 2a. Oh, and this works out perfectly. We can subtract over our b over 2a from both sides, and they have common denominators. So I get x equals negative b plus or minus the square root of b squared minus 4ac all over that common denominator of 2a. And you've probably seen this before, the quadratic formula, but this is exactly where it came from, this concept of completing the square. If we run through that with variables a, b, and c, this will give us our solutions. All we need to do is plug in a, b, and c into that, and we will have the answer. So I realize I didn't have you pause the video or try this on your own or anything. Sometimes it's really nice to see where something comes from. I don't know how many times you've encountered the quadratic formula before. You probably heard the Pop Goes the Weasel song that goes along with it. But where it comes from is just as important as what it does. It really kind of helps make sense for the situation here. So it'll let us use the completing the square process for any quadratic equation, as long as it's set equal to 0 at the beginning, without having to complete the square for everything. It's very, very useful. All right, so once again, here's that quadratic formula. We figured out where that came from. Underneath the radical sign, we've got this b squared minus 4ac. That is called the discriminant. And what that discriminant does, it's just a vocabulary term, but it describes how our solutions appear. If that discriminant is greater than 0, we will have two real solutions. If that discriminant is equal to 0, then we have one real solution because that entire square root disappears. And then lastly, if that discriminant is less than 0, it means we have a negative number underneath the square root, so we will end up with imaginary solutions. All right, and the quadratic formula also makes sense. You'll kind of see hidden in here negative b over 2a. If you think about what that represents in a parabola, negative b over 2a tells us the axis of symmetry, and then that plus or minus is telling us that, hey, from this axis of symmetry, you're going to go some distance to the left, some distance to the right to find your two solutions. So it kind of ties in graphically with that negative b over 2a that we saw before. It all connects, it all comes together. All right, methods of solving, a little typo there, solving quadratic equations. This is just kind of a nice little order of operations, I guess you could say. Nice little batting order of how you want to attack a quadratic equation. If they ask you to graph, this one takes a little bit longer to do. Sometimes we are just going to approximate answers, so the best we can do is just kind of sketch a rough graph. But it's pretty time consuming and can be inaccurate, so when approximate solutions are okay, that's not a bad choice. We can use square roots. That should be the first thing that we look for, really, if we're not supposed to graph. If it's set up in the form of something squared equaling a number, then you can square root both sides and get your answer very quickly. Factoring should be the second thing we look for. Okay. If we look at a quadratic equation and we try our factoring method really quickly, can we find the magic numbers? If we can, great, factor it. That's going to be very fast. That should be the next thing we look for. And usually if those two don't work, I would say turn to the quadratic formula. You can use that for any quadratic equation, but it works very, very quickly, and it is the process of completing the square just streamlined. Completing the square does work, but it takes a little bit more time as well. And I like the way the textbook puts this. It works for any, but it's simplest if a equals 1 and b is an even number. But quadratic formula is going to be easier in that case too. So I would say first, second, third, those are pretty good choices for how to solve a quadratic equation in as little amount of time as possible. All right, example 1. Solve the equation using the quadratic formula. Use a graphing calculator to check your solutions. All right, so number 6. 3x squared plus 6x plus 3 equals 0. Well, we may notice, this is another good thing to look for right away, if all of your a, b, and c values, those constants, are able to be simplified, if they can be divided by the same thing, we should divide both sides by that number. It's an equation, so as long as we treat both sides the same, we're good. So this becomes x squared plus 2x plus 1 equals 0. All right, and now the quadratic formula, it's in the right order. I've got a, b, c, and then set equal to 0. So opposite of b, negative 2, plus or minus the square root of b, that's positive 2 squared, minus 4 times, and I like to put this minus part in parentheses, 4 times a times c, all over 2 times a, 2 times 1. Even though there's nothing written here, we should understand that that a is a positive 1. All right, so we get negative 2 plus or minus the square root of 4 minus 4, that's going to be 0, all over 2. Oh, our discriminant was 0, so that entire plus or minus part disappears. Our answer is x equals negative 1. Sorry, I left the x equals off. Okay, so we only got one solution. Let's check that in our calculator. And I have already typed ooh, it's glitching out on me here. Well, let me open this up again. So open a new 83 plus. I had it all ready to go, but for some reason it's not liking it. So here we've got 3x squared plus 6x plus 3. And if we graph that, you can see that it sure looks like our graph crosses the x-axis at x equals -1. Now, how could we check it if it were something nastier, though? Well, the calculator has a feature. If you hit second trace, it's called Calc 0. So we want option 2. And you can see it's asking for a left bound and a right bound. It's going to scan from left to right. So we just want to toggle to the left until our point is past where we think the 0 is and hit enter. You can see it says I'm going to start scanning here. Then it asks for the right bound, so we've got to tell it when to stop scanning. So we'll move to the right and hit enter. Then it asks for a guess. Well, there's really only one 0 there, but we can get close to where we think that 0 is and then hit enter. And it tells us x equals -0.999999960. So the answer is x equals -1. The calculator just has some rounding issues. Clearly that is representing a -1. But that Calc 0 idea, if this were something much more nasty, we could find the decimal answer and then check that with the decimal answer that we got from quadratic formula, just typing that into the main screen. So we'll see if we get a nasty one, we'll come back and try that method as well. But Calc 0 can be a very, very helpful tool in the calculator. All right, so change up colors here. Number 8. Here this is set up so it's equal to 0. We cannot simplify our a, b, and c numbers, so we'll go right into quadratic formula. A is 6, b is -2, that sign goes with it, and c is +1. So we've got opposite of b, x equals, the opposite of b is a +2, plus or minus the square root of b, -2 squared, so that's a +4, minus 4 times a times c, and that's all over 2 times a. 2 times 6 is 12. So here we can tell by our discriminant that this is going to end up being a negative underneath our square root. We're going to end up with imaginary solutions, and unfortunately we cannot check those in our calculator. So x equals 2 plus or minus the square root of, that will be 4 minus 24, -20, all over 12. 2 plus or minus, let's simplify that, -20, right? We can work with imaginary numbers now. That will be 2i root 5 all over 12. And we can simplify, you notice we've got 2 over 12 for one term and 2 over 12 for the other term. What's underneath the radical, we can't touch that. Only loose numbers. So x equals 1 plus or minus 1i root 5 all over 6 is our simplified answer. Okay, all three of those pieces must be simplifiable. You know, we have to be able to divide those by the same number in order to simplify it. All right, these next two examples, number 14, here you can see we're not set equal to 0. So that should be something that we recognize right away. We want to get this set up equal to 0. So let's add 4x over to the other side. We want to get it set up in the correct order, so it's our x squared term, then our x term, then our 6. Otherwise, quadratic formula doesn't work. So our a value is -5, b value +4, c value -6. Quadratic formula, opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, and you'll see that I put all those negative signs, all that multiplication in a set of parentheses. That's just so I don't accidentally slip up in my order of operations. There's a lot of things happening here. -4 plus or minus the square root of, that'll be 16 minus a positive number, right? Inside I've got a negative times a negative. So that'll be 16 minus 120 all over -10. So again, we are going to have imaginary solutions because what's underneath our radical will end up being negative. x equals negative 4 plus or minus the square root of negative 104 all over negative 10. X equals 104. We've got 2 and 52. We've got 2 and 26. We've got 2 and 13. So we do have a pair of 2's, but then 2 times 13, neither of those have a pair, so that stays underneath. So negative 4 plus or minus 2I root 26 all over negative 10. And we notice that all of these are divisible by 2. So we've got negative 2 plus or minus I root 26 all over negative 10. And since we've got a negative 2 and a negative 10, we can actually multiply top and bottom by negative 1. And just so we end up with a positive denominator, it cleans it up. So 2 plus or minus I root 26 all over 10. All right, and notice that multiplying by negative 1 did not affect this I root 26 because it already had both signs attached to it. It didn't matter. All right, let's try number 18. Got to get it set equal to 0, get it set up in the correct form. So we got 4w squared minus 7w plus 6. Get it set equal to 0, squared, regular, just a number. All right, that means our solution, in this case it's w, opposite of b, plus or minus square root of b squared minus 4 times a times c all over 2a. W equals then 7 plus or minus the square root of 4 times 4 is 16 times 6 is 96. So 49 minus 96 gives us a negative 47 all over 8. Now, a lot of imaginary solutions in this set of notes. W then equals 7 plus or minus I root 47 all over 8. This was a case where we could not simplify the radical, could not divide out the same number from the pieces of our numerator and the denominator. Now, if we were to graph either 14, 18, or our previous example, number 8, we would see parabolas that do not cross the x-axis. That's what would show us that they have imaginary solutions. All right, example 2 here. This is not as much work. Find the discriminant. Remember, that's just under the square root. Okay, so really just think about that part of the quadratic formula. B squared minus 4ac. That's all we're looking at. We don't need anything else. So my a is negative 1, my b is positive 2, my c is 12. So my discriminant is going to equal the square root of b squared minus 4 times negative 1 times 12. That discriminant equals the square root of 4 minus 4 times negative 1, negative 4 times 12. So that'll be plus 48. That discriminant is the square root of 52. It's positive underneath. That means we've got 2 real solutions. Number 26, let's get that set up in standard form. We need to subtract that x from both sides and put it in the proper order. My discriminant is going to equal square root of b squared. My b is negative 1, so if I square that, it'll be positive 1, minus 4 times a times c. All right, so we clean that up. We get this square root of 1 minus, this will be a positive, so minus 48. Discriminant is the square root of negative 47. Since that radicand, what's under the square root, is negative, we've got 2 imaginary solutions. Now notice for the discriminant, we really didn't need the square root, but I like to keep it in place. The discriminant is really what's underneath But by having the square root in place, I don't know, the fact that it comes out negative, that just kind of jumps out that, hey, it's underneath the radical, that means imaginary. So I always like to include the square root when I do that. That's just personal preference, though. All right, third example, the area of the triangle is 8 feet squared. Solve for x. Well, area of a triangle, 1/2 times the base of that triangle times its perpendicular height. So in this case, the area of 8 feet equals 1/2 times the base of x plus 1 feet times the height of 3x minus 7 feet. 8 times 1/2 times, let's FOIL this out, we've got 3x squared, we've got minus 7x, we've got plus 3x, and then we've got minus 7. A lot of work here just to get this equal to 0. 1/2 times 3x squared minus 4x minus 7. 8 equals, let's distribute the 1/2, 3/2 x squared minus 2x minus 7/2. Then we need to subtract 8 from both sides to get that set equal to 0. I'm going to call that 8/16/2 to set up a common denominator. So now 0 equals 3/2 x squared minus 2x minus 23/2. All right, and our solution now, x is going to equal the opposite of b, positive 2, plus or minus the square root of b squared, that's 4, minus 4 times a, which is 3/2, times c, which is negative 23/2, all over 2a. 2 times 3/2 is just 3. Well, there's a little bit of fraction multiplication happening. 2 plus or minus the square root of 4, and then 4 times 3 divided by 2 times 23 divided by 2, that 4 is going to cancel out those divided by 2's. So I've got 4 minus a negative 69, so plus 69 all over 3. X equals 2 plus or minus the square root of 73 all over 3. And now if it's the area of the triangle coming out to be positive, and we've got side lengths that are x plus 1 feet, if we really wanted to construct that triangle, we could not have negative side lengths. So really our only solution should be 2 plus square root of 73 all over 3. And our last example here, an archer is shooting at targets. The height of the arrow is 5 feet above the ground when he starts. Due to safety rules, the archer must aim the arrow parallel to the ground. Recall that falling objects follow that pattern. We saw this in Chapter 2, negative 16t squared plus our initial height. Remember, y's mean height. So hopefully the archer can hit this target. Obviously, this is not to scale. How long does it take for the arrow to hit a target 3 feet above the ground? So we're trying to answer how long. That means we're trying to find t. And if the target is 3 feet above the ground, that means the arrow's final height is 3. Negative 16t squared, and its initial height was 5 feet. So now we're just solving for t. This looks like a pretty simple process here. So I've got negative 16t squared equals, if I subtracted 5 from both sides, negative 2. That means t squared equals negative 2 divided by negative 16, 1/8. And if we square root both sides, we find that t equals plus or minus square root of 1 over square root of 8. And we could multiply top and bottom by square root 8. We don't want to end up with a radical in the denominator. Find that t equals root 8 over 8 seconds. Now you'll notice I only took the positive result there. It's because we're talking about time here. We cannot go back in time, so we want a positive measure for our answer that is measuring time. Here's a look at your assignment for section 3.4.